Hello, ladies and gents. In this video, we're going to take a look and we're going to do some guided exam question practice on the 2018 question on the Leaving Cert chemistry paper on bonding and shapes. I don't have the question number here, but I imagine it was question 5. That's where this stuff normally comes up. It's what 25 marks for this section, so it's a half a full question, so you have 10 minutes. So you know what to do, grab your timer, set it for 10 minutes, and we'll get started. Okay, so let's break it down. Let's start reading the blurb as we normally do. And it says here that both carbon disulfide, which has this formula, CS4, and tetrachloromethane, which is CCl4. So let's just break this down for a second. Tetra, this word means 4, chloro, so 4 chloros on a methane. So most of us will understand that methane is CH4. And if we have tetrachloro, that means that we've replaced the 4 hydrogens with 4 Cls. So CCl4. So that's the formula. They're both colorless liquids at room temperature. Okay, so not really anything important there, but the formulas are important. So they're giving you some information there that is important. Right, straight up, first question is a straight up definition worth 6 marks. Define electronegativity. So what we're going to do is we are going to lay out our question and we're going to begin by at the side of the page. Always a good idea to clarify what it is that you're doing, because this is good for your practice and linking ideas. So electronegativity, definition, pause the video and write down the definition for that now. All right, so at this stage, this video isn't about teaching you what electronegativity is. If you want to know what it is, you need to go back and find my video on electronegativity. What is electronegativity? The definition is it's the relative attraction an atom has the shared pair of electrons in a covalent bond. Again, if that makes no sense, so just quickly, relative attraction an atom has for the shared pair of electrons in a covalent bond. That doesn't make any sense. You don't understand what electronegativity is, then this isn't a good. You shouldn't really be doing this video yet, because you're not going to understand any of the rest of it. So only do this if you've covered this in class. All right. So relative attraction an atom has for the shared pair of electrons in a covalent bond. So straight up definition, we know what that means. It means it needs to be word perfect. All right. Let's go and look at part 2. It says predict. So make a prediction about the type of bond formed between the carbon and the chlorine atoms in a CCl4 molecule. So predict. First of all, what I'll do is I'll draw out the molecule for you, and this is a good idea for you to start drawing, for you to practice this as well. A CCl molecule looks like this. A C in the middle, surrounded by 4 chlorines. And what we want to know is what type of a bond is this here? Okay. So if you know how to do this, you don't need any more help, pause the video, go find out what type of bond is that. All right, if you don't need any, if you do need a little bit of extra help, you have no idea how to get started here, then I can give you some hints as to where to go. But you should know how to do this. If you've never done this before, then don't be doing this question. Okay, so what we want to do is we need to find out the electronegativities of these 2 elements. Where do we find this information? We find it in our log table. So if you have log tables, open them up. Look in your index for where is the table of periodic table of electronegativities and go find it. Or if you don't have log tables at the moment, you can Google one, find periodic table of electronegativities. What you should get is something that looks like this, a periodic table, but you have atomic numbers on the top, and on the bottom you have numbers that are not the mass number, they are the electronegativity values. So this is taken from the log tables. So our 2 elements that we're talking about was carbon and chlorine, here and here. So carbon is 2.55 and chlorine is 3.16. So what I'm going to do is I'm going to go back. I need to remember those numbers. It's better if you have them beside you, 2.55 and 3.16. So what I'm going to do is I'm going to write on here, the chlorine is 3.16 and the carbon is 2.55. So what you want to do when you're trying to find out what type of bond it is you find a difference between them. So go ahead, pause the video and write the difference between them. Do that now. Okay, so we're going to do 3.16, and to find the difference, we want to take away the other one, 2.55. Get the calculator out, find the difference. Do that now. If you haven't done it already, pause the video and do that. And what you should get is 0.61. So the difference of electronegativities between carbon and chlorine is 0.61. Now, 0.61, there's a range that we need to know. Okay, so how to work out whether this is polar covalent, non-polar covalent, or ionic. There's 3 ranges that you need to know. So if you know those ranges, pause the video and write them down now. Again, it's good to, in revision to keep writing this stuff out. So if your difference is 0 to 0.4, what does that mean? What type of bonding does it have? So again, good idea as revision to do that now. If the difference is 0.4, the range goes up to 1.7. That's the next type of bond. And if it's greater than 1.7, that means that tells us something else about the bond. So what type of bonds fall in these ranges? Pause the video and fill this out now. Okay, so if it's the differences between 0.0 and 0.4, then that means that this type of bond here between carbon and chlorine would be non-polar covalent. Non-polar covalent. If the difference is greater than 0.4 but less than 1.7, that means it's polar covalent. And if it's greater than 1.7, that means that the bond is ionic. And where does ours fit in here? 0.61 fits into this range right here. It's between 0.4 and it's not, so it's greater than 0.4, but it's not greater than 1.7. So that means that this type of bond is polar covalent. Now, you might know this here in your head, and you don't need to write that down to get the marks, okay? But it's always good when you're revising to keep just refreshing yourself on that stuff. That's why I went ahead and wrote it down. You might know the range in your head, and you might see 0.61, you go, okay, I know where that is polar covalent. You don't need this table, but when it's practice and it's not the real thing, the more that you do this, the better. So that's why I drew it down. I suggest that you would do the same. But the correct answer here, this is what you need. You need polar covalent. That's the final answer. All right, the next little bit, sorry, is what is the valency of the carbon in tetrachloromethane? So next part is part 3, and it's the valency. If you know what that means, go ahead, pause the video, write down the answer. All right, if you don't know what that means, so here's a hint for you. It's how many bonds the carbon has formed. Pretty straightforward. Valency refers to how many bonds are made by that atom. So now that you know that, pause the video, write it down. Okay, so it's the valency of carbon in this molecule. Again, if you didn't get this yet, pause the video, write it down. All right, so carbon has made 1, 2, 3, 4 bonds. So in this molecule here, valency of carbon is 4. Okay, so that's the valency of carbon. Correct answer is 4 there. Right, next bit. That was nice and easy. Next bit, state. So this is one thing I asked you to do, and account. So 2 things. I'm going to lay out the next bit, a state and account. This means you can't, this is great practice, get into it. It means you can't forget to do one of the bits. So state, so I see state, and I'm going to lay out my question and account. Good to keep these separate and lay out the question, then you cannot forget to do it. So what does it, now I'm going back and seeing what it actually says to do. So state and account, I've laid it out for the shape of the tetrachloromethane molecule. So state, what shape is it, and account for it. Right, so state, what shape is this molecule? What's the name of that shape? Pause the video, write it down. Okay, what I should have said is this is a tetrahedral molecule. Tetrahedral. Again, if you've never heard of that before, you are doing the wrong question. You should not be doing this yet. Go and watch the videos that I've made on shapes of molecules. The next question is account. It says to account for. Why is it tetrahedral shape? So pause the video. What makes this up here be a tetrahedral shape? Pause the video and do that now. Okay, if you didn't talk about the number of bond pairs and lone pairs, then you need to do that now, because that's what decides what the shape is. Pause the video and write an answer. Okay, so the account for here would be that the carbon has 4 pairs of electrons around it. That's the first thing. Electrons around it, which makes sense because 4 pairs is 8, and that gives carbon a share of 8 electrons like it wants to. It has a stable octet now, or it's achieved the octet rule. That's a good thing. It has 4 pairs of electrons. How many of them are bond pairs and how many of them are lone pairs? So pause the video, count them there, and figure out how many lone pairs, how many bond pairs are in this here. All right, so straight away, you should be able to see that there are 4 bonds around carbon, which means that all the pairs of electrons are all in bonds. So that means we would say that carbon has 4 bond pairs and 0 lone pairs. Okay, so how does that make it a tetrahedral? Pause the video and do that now. Okay, well, this means that all pairs are equally spread in space, because there's no lone pairs that have a greater repulsion, equally spread, which gives a bond angle of 109.5, and we call this a tetrahedral. Okay, so account for, well, its carbon has 4 pairs of electrons around it, and all 4 are bond pairs. There's no lone pairs. If it had a lone pair, then that would change the shape. Okay, but it doesn't. It has 4 bond pairs. They're all spread equally out, which gives it a bond angle of 109.5, makes it tetrahedral. Next bit. Draw. So you're asked to draw a dot and cross diagram to show the arrangement of all the valence shell electrons in a CS2 molecule. Next bit. Last little bit here. It's part 5. And we're asked to draw. So that's the action word, what it wants us to do, draw, and it's CS2. We want to show all the valence electrons around it. So I want you to start by drawing the carbon. Carbon's the central atom. Draw the carbon and how many valence electrons it has. Pause the video, do that now. Okay, so if you haven't already done this, carbon is in group 4, which means it's got 4 valence electrons. Okay, so if you draw the carbon, it's got 4 valence electrons. Now, in a tetrahedral, we would draw the electrons like this, 4 equally spread out electrons. But in this case, they're not going to be like that, and that's because it depends what it's combining with. It's only combining with 2 atoms, not 4. It's combining with 2 sulfur atoms like this, which means that we're going to put a sulfur on each side, like this, sulfur like that. And the sulfur has 6 valence electrons like this, 1, 2, 3, 4, and then they're going to have to share a pair to get 8, which means that they're sharing 2 pairs with the carbon. Count up the valence electrons on this left-hand sulfur now. You've got 2, 4, 2, 4, 6, and a share of these is 8. So this octet rule has been satisfied for that sulfur. Well, and it's the exact same. The opposite side is identical. You've got 6 valence electrons around this sulfur. 2 of them are in bonds with the carbon. And you'll see here that this adds up because the carbon should have 4 valence electrons, which you see it does, the 4 dots. Okay. And then the sulfur has a full octet as well. So this is exactly what it should look like. This is CS2, and the shape is linear. Why is it linear? Well, there's no other lone pairs on the carbon, so they don't skew the bond angle or anything like that. So it's linear. And that's it, guys. That is that question done. So that is the shape. Now make sure you show all of the electrons, because it clearly, if we go back to the question, look what it said here. It clearly says in the question, show the arrangement of all the valence electrons. Arrangement of all the valence electrons. So that means that you need to show dots and X's for every atom. We'll leave the marking scheme here so you can see for yourself, go through it, make sure that you would get all of the marks there, or else see where you lost them and make a note of those. Again, anything that you don't get right, you should put it on a little study card or a flashcard and keep that. Ones you're getting right all the time, don't need to spend too much time on. It's the other ones that you need to spend time on, the ones that you're getting wrong. All right, guys, that's it. If you got something, if you enjoyed this video and you think it helped you, do give it a like, because it helps other students to find it. And if there's any particular question that you can't do by yourself and you want me to help you, stick it in the comments below and I'll try and make a video to help you.